Hello all. In this video, I will discuss atomic absorption spectroscopy, principle, instrumentation, and applications. Atomic absorption spectroscopy is useful for trace element analysis. Metals that can be detected by AAS are listed here. Spectroscopy is the interaction of the electromagnetic radiation with matter, that is, atoms or molecules of the drugs. Spectroscopy is of two types: absorption spectroscopy and emission spectroscopy. Emission spectroscopy examples include fluorimetry, flame spectroscopy, atomic emission spectroscopy. Absorption spectroscopy examples include UV visible spectroscopy, IR spectroscopy, NMR spectroscopy, atomic absorption spectroscopy. In this video, we will discuss in detail about atomic absorption spectroscopy. Principle of atomic absorption spectroscopy. When monochromatic radiation is passed through the sample which contains atoms, the atoms absorb the UV light or visible light and they get excited to the higher energy state. So the rate of decrease in intensity of the radiation is proportional to the concentration of the solution. This is the principle of atomic absorption spectroscopy. Instrumentation of atomic absorption spectroscopy. The components of the instrument are light source, sample cell, and detector. This is the schematic representation of atomic absorption spectroscopy. Source of light, flame, wavelength selector, and detector. There are two types of the instruments. One is single beam instrument. This is single beam instrument. Second one is double beam instrument. First component in the instrument is hollow cathode lamp. Hollow cathode lamp is a source of light. The hollow cathode lamp is filled with argon gas or neon gas at a pressure of 1 to 5 torrs. It contains cathode and anode. Cathode is cup-shaped cathode is present. It is coated with metal of interest and tungsten anode is present. Suppose we are analyzing cadmium. Cathode is coated with cadmium metal. When potential of 300 volts is applied, inert gas present in the lamp will ionize. Inert gas ionizes. This gaseous ions will accelerate towards the cathode and dislodge the excited metal atoms. So finally, it results in the atomic cloud of metal atoms. This process is known as sputtering. Excited atoms emit the element-specific radiation. This is the working of hollow cathode lamp. Diagram of hollow cathode lamp. It shows a cylinder in which neon or argon gas is filled at 1 to 5 torr and it contains anode and a cathode. Cathode is coated with the metal of interest and this is anode. Second source of light is electrodeless discharge lamp. Electrodeless discharge lamp contains quartz tube. This quartz tube is filled with inert gas at low pressure. This bulb contains small quantity of element of interest. This detector contains small quantity of element of interest. When light incidents on this metal, when light incidents on the gas, it causes ionization of the gas. How the radiation is produced? Radiation is produced by the radio frequency source. Ionization of the gas results in gaseous ions. Inert gas ions are produced. These inert gas ions cause excitation of the metal and these excited atoms return to the ground state by the emission of the light. So this is the working principle of electrodeless discharge lamp. Diagram of electrodeless discharge lamp, which shows quartz tube, RF coil and metal of interest. This is metal, this is RF coil and this is the tube. Second component is atomizer. Atomic absorption spectroscopy requires analyte atoms in the gaseous phase. So how to convert the liquid sample into gaseous phase, gaseous atoms? There are some steps in the conversion of the liquid sample solution into the gaseous atoms. First, the sample must undergo dissolution and then vaporization. These two steps are possible only with the atomizer. The two atomizers used are flame or graphite furnace. Flame atomic absorption spectroscopy, flame can only analyze the solutions, while graphite furnace will accept solutions, slurries, or solid samples. Atomization technique. Sample atomization techniques are flame atomization, electrothermal, hydride atomization, and cold vapor atomization. Flame atomization and electrothermal atomization are commonly used techniques for atomization of the samples. Atomization is separation of the particles into individual molecules and breaking the molecules into atoms. So there are some steps in the atomization process. So first step is the liquid sample by the nebulizer, it is converted to the aerosol form. This aerosol undergoes dissolution to form solid. The solid undergoes volatilization by the heat, and it undergoes volatilization by the heat energy, and it gets converted to the gaseous molecules. These gaseous molecules undergo dissociation and form atoms. Second atomizer is electrothermal or graphite furnace atomizer. This graphite furnace is used to vaporize the sample. So here the sample is deposited in the small graphite coated tube, which can be heated to vaporize and atomize the analyte. It is more sensitive than the flame atomizer. It can be used for trace metal analysis in parts per billion range. Graphite furnace. This is the diagram of the atomic absorption spectrophotometer, in which atomizer is graphite furnace, source of light, atomizer, monochromator, and detector. Graphite furnace diagram. So we have discussed two components of the instrument. First component is source of light, second is atomizer, and third component is monochromator. Monochromator, function of monochromator is to select the specific wavelength of the light, which is absorbed by the sample, and to exclude the other wavelengths. Last component is detector. The light from the monochromator is directed towards the detector. Here detector used is photomultiplier tube, whose function is detector uses photomultiplier tube, whose function is to convert electrical signal into light signal. Photomultiplier tube, the tube contains one cathode, 8 to 10 diodes, and an anode. When light incidents on the cathode emits the electrons. The electrons are accelerated towards the first diode. Here the first diode is maintained at 90 volts more positive potential than the cathode. So the electrons are accelerated towards the diode and they are multiplied by the first diode. The tube contains several diodes and all are maintained successively at successively increasing potential of around 90 volts with respect to the preceding diode. So here the second diode is maintained at a potential of higher potential when compared to the first diode, and third diode is maintained at a higher potential when compared to the second diode. In this way, series of diodes are present and the electrons are multiplied. Finally, the 8 to 10 times, the electrons are multiplied by 8 to 10. Several 8 to 10 diodes are present, so the electrons are multiplied and finally several electrons reach the last diode and these electrons are collected by the anode. So this is working of detector. Applications. Data analysis and applications of atomic absorption spectroscopy. Atomic absorption spectroscopy is used in agriculture for analyzing soil samples and also chemical analysis, environmental studies like water contains traces of lead and mercury as impurities. The trace amounts of lead and mercury can be analyzed by the absorption spectroscopy, and in food industry also atomic absorption spectroscopy is used, and in forensic labs also atomic spectroscopy is used. Here the forensic scientist can perform in-depth analysis of blood samples, brain, muscle tissue, and common causes of metal poisoning like mercury and lead poisoning are easily detectable by using this technology. Thank you. And one request, if you like the video, like kindly like, share and subscribe.